Hey y'all, it's Mr. Kyle Myers Mathematics. Let's just jump into it. This is number 57. We're almost done with these. These are crazy long, and the instructions are a little crazy as well. Let's go ahead and look at it. Newton's method seeks to approximate the solution f of x equals 0 and starts with an initial approximation x sub 0 or x naught, and successfully defines a sequence x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. For the given choice of f and x0 or x naught, write out the formula for x sub n plus 1 if the sequence appears to converge. Give an exact formula for the solution x, then identify the limit x accurate to 4 decimal places and the smallest n such that x sub n agrees with x up to 4 decimal places. Okay, so what we want to do is I like to begin with the end in mind, and we have the answers pulled up, I believe. Yeah, I did for the other one with 55, because I was curious what they thought the answer was. I actually disagreed with part of their answer, and I might disagree with this one as well, because they're showing the same n value. They're saying n equals 5. And on 55, they said n equals 5. I thought it was n equals 3. At least that's what I got from the work that I did. If I'm wrong, let me know. Let me know why I'm wrong. But that's what I got. So we'll see what happens here. I have the answer pulled up off to the side. I put the answer in the problem for 55 just because the directions are kind of crazy. But what they want for answers are they want you to plug in f of x sub n and f prime of x sub n. They don't really want you to simplify it that much. They want to know what x is actually equal to, so they actually want you to plug in 0 for f of x and solve for x so you know what you're looking for, which I think is a good idea anyways, because you should begin with the end in mind. So I think that's what I would probably do first anyways. And they want to know what x is approximately equal to 4 decimal places, and they want to know the n value. And that'll be the very last thing that we get to, is that n value. So we'll more or less go in the order that they're looking for the answers for here. I'm looking over at my monitor so I can make sure I'm writing underneath where my big old bald noggin is. So let's see. So 0 is equal to ln of x minus 1. So I'm plugging in 0 for f of x. And we're going to solve this. So we'd add 1 to both sides. The ln, the log natural of x, is a log base e. So if I did e to the power of both sides, then I would end up with e is equal to x. That's one way to do it. Or you could do the change of base. I use the phrase the base stays the base and the others switch place to help me to work it all out. So remember that ln is a log base e. ln of x is log base e of x. So the base stays the base and the others switch place. I wrote it out on the previous problem, number 56. So go check that out if you want to see it written out for you. But that's the phrase I use. The base stays the base and the others switch place. So the base would be e, and then the other switch place. It would be e to the first power instead of e to the e to the x. It's not actually e to the x, but it's like up and to the right from the e. And then instead of it being equal to 1, it would be equal to x. So the base stays the base and the other switch place. That would also get me this answer. So x is equal to e. E is about 2.718. I know 3 decimal places of accuracy for that. I don't know 4, but fortunately the answer is right here. So 2.7183 would be the next decimal. 2.7183. There we go. So that's 4 decimal places of accuracy. That's what we're shooting for. If it's more than that, awesome, but it has to be at least that much. So this is part of the answer, all of this stuff. This is going to answer a couple questions here. So this is going to answer right at the formula. We haven't done that yet. If the sequence appears to converge, give an exact formula for the solution x. Newton's method is supposed to always work. The only time it might not work is if the value we're shooting for doesn't exist. But the value does exist, so it should converge, and we would write out the convergence. They don't actually write out the limit in the answer key, but I'm going to because I think it's a good idea. The limit as n goes to infinity of x sub n would then equal e, which is approximately 2.7183. So that is the sequence appearing to converge. It is appearing to converge to E. Give an exact formula for the solution X. I believe that is answered with this other boxed in part over here. So this is part of an answer here and here. Identify the limit X. Here we go. Identify the limit X accurate to 4 decimals. That's actually, I kind of did that in two parts. Like this is the limit, and then that limit is approximately that, accurate to 4 decimal places. Okay. So we've got a lot of it. Probably the next thing I want to do then is go ahead and take the derivative. So, oh, I wanted to switch to white. Switching back and forth here. So f of x is equal to ln of x minus 1. So if I take the derivative of that, the derivative of ln x is 1 over x, and the derivative of any constant is 0. So that would be my f prime derivative. And then I go ahead and plug that into the quasi-recursive formula thing going on here. So x sub n plus 1 equals x sub n minus, and then it would be f of x sub n. So I'm just plugging in x sub n in place of x. So that'd be minus ln of x sub n minus 1. All right, so I'm just plugging in. It's just f of x, but with an n. And then the derivative, but with an n. So it's 1 over x sub n. So that's a little sloppy because it's a fraction. It's a fraction, but then there's a fraction in a fraction. So I do want to clean that up a little bit, and probably won't clean it up too much though. I'm gonna the denominator of a denominator is the numerator. The denominator's denominator is equal to the numerator. Or you could just do keep change flip, that would work as well. So this would end up being minus, it'd be x sub n minus x sub n ln of x sub n plus x sub n. I'm going to squeeze that in there. So it actually ends up simplifying even more. I'm not even going to have space for a table. So x sub n plus 1 is equal to, and then this would be x sub n. That's going to be x ln of x sub n times an x. Got that? And then that minus would get distributed because it's minus like this. So that's why that minus times is by this one and gives us a plus. And then it's 1 over x sub n, which is x sub n. So I'd end up with 2 x sub n minus x sub n ln of x sub n. That's also a mouthful. There's a lot of mouthfuls in this problem. We're going to try to squeeze this in so I don't have to scroll or move the board around. I try to avoid that if I can. We're going to squeeze these in here because we need to get accurate to 2 decimal places. Oh, by the way, that is part of the answer. For the given choice of f and x, write out the formula. So this is the formula. And this would probably be what I would lock in, just because it definitely seemed like we could clean it up and make it look a lot nicer. So I would probably lock the nicer version in, write out the formula. So we got that checked off the list. The last thing to check off the list is the smallest n value such that x sub n agrees with x up to 4 decimal places. Okay, so then x sub n would go here. And we know that when n is 0, x sub 0 is 2. And I probably would have done a 3 because 2.7 rounds up to 3. But maybe Newton's method works where you have to like start with the rounded down number. In the past, it already rounded down on the last couple problems. I've said this on, I don't know, 53, 54, something like that. But this Newton's method of approximating solutions, I've actually never seen this before. So this is my first time doing this too. It's just, maybe I missed that day of class, or I wasn't paying attention. I was sleeping. I don't remember exactly what happened, but this is like completely new to me, so I'm kind of learning this along with you guys. I mean, don't get me wrong. I know Calc 2 like the back of my head, but there's these like random topics that you're like, wait, what? Did I learn that? So n equal to 1. So what I'm going to do, and I did this on the last problem, but I'm going to do this on here as well. Now, granted, the answer key says n equals 5, but I might end up disagreeing with them because I ended up disagreeing with them on the previous one, 55. I'm going to bring this over here so you guys can see this. This is going to be, so the cleaned up version is that. I'm going to go ahead and type that in. So f of x equals, so I'm treating this like it's an explicit formula, but it's not. So don't pay attention to the graph. These are not the droids you're looking for. 2x minus x ln x. That's what I'm going to type in. And the ln of 2, that was from the previous thing as well. We're just looking for e, right? So that's what we're looking for. That's the goal. And what are we trying to find? So let's start off with f of what? So we know that when n is 0, x sub n is 2, so x sub 0 would be 2. So if we're looking for x sub 1, then we want to type in 2 for x. Okay, remember, it's the recursive formula. So I'm typing in 2, because then what I would be doing is I would be saying, okay, well, when n is 0, I would have x sub 0 plus 1 equals 2 times x sub 0 minus x sub 0 ln of x sub 0. But what is x sub 0? X sub 0 is 2, so I'm typing in 2 for x. So hopefully that makes sense. I'm using a formula, and you can do this on a graphing calculator as well. It's just a little easier with Desmos, and also it's Desmos, so I'm going to use Desmos. But this is going to tell me what x sub 1 is. So it's already not that bad. It's not accurate to any number of decimal places yet, but it's only off by 0.1. So it's already pretty close right from the get-go. I'm going to just type in 2.6 because it's not accurate to any decimal places yet. So I'm going to type in 2.6. 2.6. Right? So it's not accurate to any decimal places yet, but we'll see. Okay, next step. What I'm going to do is this answer that I get is irrational because I'm plugging it into this formula that's doing x times ln of x. So I'm ending up with an irrational answer. There's no way to write this as a fraction. If I could write it as a fraction, there would be a little fraction thing that shows up over here, and there is not. So what I'm going to do is, to try to maintain total accuracy here, I'm just going to click on it, and then it highlights it, and then I Control C copy, and then I'm going to Control C or Control V. And so that now plugs the next one in, right? It's recursive. So I'm taking the previous answer and plugging it in to get the next answer. So this is so this is now the next in value. So now it's accurate to a few more decimal places. Now, when n is 2, I have 2.71, and that's actually as far as it goes, 2.716. I'm going to write it out to 3, just because if I round to 2 decimal places, I would say 2.72. Or I could just put 2.71 ... right? I could go ... 2.71 ... So ... for this guy, right? It keeps going. 2.71 ... So it's accurate to 2 decimal places now. And I have a feeling like on the third one, that's going to be the charm. That has been the way it's worked so far. Pretty much all of these answers. By the time we get to n equals 3, it's accurate. It's pretty accurate. This method of computing, like approximating stuff, is actually pretty accurate. I have no idea how this formula actually works. I've never really looked into it. So I'm going to Control copy. If you can't do that, by the way, if you're on a graphing calculator, just write it down and then just write out all the decimal places, and then at least 10 to try to have as much accuracy as you can. And then Control C, so Control V, and now that should be it. 2.718. Oh, it's not. 2.7182, but it's 2.7183. Oh, wow. This is the first time this has happened. So I'm actually getting 2.7182. So I'm going to write 2.718 dot dot dot. 2, come on, 2.7, it's being slow, 1, 8, dot dot dot. So I'm not going to have space to write out the fourth one, but I feel like the fourth one is going to be the charm. Fourth time's the charm. Isn't that how the saying goes? So control copy, and then highlight all this, control paste, and that should do the trick. Yeah, 2.718. Oh, it's still not. What? It's still not accurate. We might actually make it to 5 here. 2.71828. It's still got the 2.8 thing instead of the 3. Wow. Am I just, hold on. Oh, wait a second. Okay, so if I round, hold on. So if I round, I was going based off of the fourth decimal place rounding, which is 2.7183. But actually, no, I take back what I said earlier, because 2.718, so this is the third one. I'm getting the fourth one. But this one right here was the third one. This was n equals 3. And this is actually accurate to that. I mean, it's actually even closer. So 2.718, 28, 1, 2, 3, 4, 5, 6. So actually, this is like crazy accurate. It might actually be in, let me go back to n equals 2. So we're gonna have to recursively do this because I only went to 2.6 here, but it's definitely at least n equals 3. I went too far. So let's go back to 2. So 2 gives me this. Control copy, paste. Okay, 2.716. Okay, yeah, so that was 2.71. Okay, so that was n equals 2. And then for n equals 3, I get 2.71828. Yeah, there we go. So n equals 3 again. That's what I was thinking. So all of them have been n equals 3. So n equals 3 is the answer for that. Now they don't put that. They write it as n equals 5, and I disagree with them. I think it's n equals 3. N equals 3 is what I would lock in. I'm not sure why the answer key has it that way. It could be that I'm missing something, because again, this is like a new topic for me, so I'm a little fresh with this, or at least I don't remember, learning this before. But I'm gonna lock in n equals 3 because we are accurate to like 5 decimal places, not much less 4, when n is equal to 3. So it is definitely accurate at least to 4 decimal places by the time n is equal to 3. And that will do it. So yeah, hopefully that's been helpful. You guys can catch the 5 math mistakes everyone makes and how to avoid them. That is a free PDF on my website, myirishmathematics.com, that you can go check out. And I'll catch y'all in the next video. Blessings, y'all.